Okay. So, for the rest of our time, we're not going all the way through the first and second page. We're going to just do a little bit more of a refresher with inequalities. And so the first thing I'm going to have us do is write down what it means to be a solution to an inequality. Okay? Can somebody give me a solution to x is less than 3? Give me a value that would make that true.
47.
X is less than.
I thought it was greater.
Okay, so give me one that would be less than then.
-2.
-2. Okay, so now, is -2 the only solution to this? No. And so a solution to an inequality, that's why we graph it with an open circle and a line, because it's not just one number. It's a bunch of numbers, a lot of times. So for a solution to an inequality, I'm going to write any value that makes the inequality true. Okay. And so to check if it makes the inequality true, what we do is we put it in for our variable, which in this first example, what's our variable? X. And so let's check and see, does 3.6 make this true? So we're going to write it down. I'm going to hammer you guys this year for write down your work. What are you doing? You got to show me, okay? I don't want to see an answer. I want to see your process. So I'm going to write -3. If there's an X right next to it, that actually means what? Times, so I'm going to do a parentheses, times 3.6, I put it in for X, plus 2, greater than or equal to -14. And I'm going to put a little question mark at the end. I don't know. I'm checking that. That's what I'm checking. Have you seen a parentheses before for multiplication? Okay, good. So now, if you're not really keen on doing 3 times 3.6, go ahead and do it on the side if you don't have a calculator with you. But if you do have a calculator, let's see what we get when we simplify the side, okay? So I'm going to do -3. We're going to turn it on first. Oh, look, it's still up there from last hour. What did I get? Okay. So I'm going to write down, all right, -8.8 is greater than or equal to -14. And now this is where I have to actually think. Ooh, don't let me down. Because now I remember the question is it? I need to figure it out. Some of you might be thinking, nope, 8 is not bigger than 14, and you are right, 8 is not bigger than 14, but that's not what this says. This is saying -8.8 on the number line. To be bigger than, it's got to be to the right of it. Is -8.8 to the right of -14 on the number line? Yes. So is this true? Yes. Okay, so over here, I'm going to just draw a little picture. Here's -14. And -8.8 is somewhere over here. It's definitely greater than. It's further to the right. Because then 0 would be somewhere over here, right? Okay, cool. So now we just spent like at least 10 minutes or so, 15 minutes doing a foldable on this. I want you in your head to form an inequality for this. Think about, what does this mean? Anybody want to tell me? If you're like 100% confident, you think you know it? 100% confident. Anybody want to share? Yeah.
I believe it's X is greater than -3.
Okay. Nathaniel, or do you go by Nate?
Yeah.
Is that what you were gonna say?
Yeah.
What's it? Hey, since we're on you, what's another way I could write that? Awesome. -3 is less than x would be a second way I could write that. Those would be the only two solutions to that. Not solutions, I shouldn't say that word. Only two correct inequalities. Okay, wonderful. Then the last thing I want to talk about today before we move on to homework is this word domain. So has anybody heard this word domain before in math? Anybody know what it means? So I'm going to write this down. Domain values are inputs. Inputs. What does input mean? So input would mean something I put into, rather than output would mean something that comes out. So inputs means these are things I'm going to put in for x. For instance, on that one example I did a couple back, what did I put in for x? What number? Yeah, the 3.6. That was a domain. That was an input. Okay? But sometimes in general I want to describe what kind of numbers are domains. So I'm going to say what would be the acceptable or appropriate values. What are acceptable or appropriate values for input? Okay. And so sometimes that doesn't matter when it's just x is greater than 3, okay, as much as it does when we have like word situations. Okay. So if I was talking about the weight of something, and I wanted to talk about the weight of a baby, let's say. Is any kind of number okay for the weight of a baby? Or appropriate, I guess? Can you think of what kinds of numbers would not be appropriate for like the weight of a baby? I heard negative. Right? So sometimes I might say that that an acceptable or an example of domains might be positive numbers. Sometimes we were talking about last hour, what about if I had a really, really cold day in January and I knew the temperatures were below 0 the whole time? Then what would be the appropriate numbers for that? What kind of numbers? Negative numbers sometimes can be kinds of input. I know. Sometimes we don't want fractions or decimals. Does anybody know what those numbers are called? 0, 1, 2, 3, 4. We have a name for them. It starts with a W. Whole numbers? Have you heard of whole numbers before?
Yeah.
Okay. Now, did it screw you up that it starts with a W?
Yeah.
Because whole numbers is spelled W-H-O. Oh boy. Alright, so sometimes whole numbers, like for instance, if I was talking about how many apples I bought at the store, those would be like whole numbers. I don't buy like a quarter of an apple or so on. Okay, does that make sense for that word domain? It's just input, and they're just kind of the appropriate or kinds of numbers that describe what can we put in? What kinds of things are these? A description, really. Alright.